Alright guys, welcome back. We're going to be solving another question from the fundamentals of electric circuits. And in this one, we know the current flowing past a point in a device is shown in this figure on the right hand side. And we need to calculate the total charge through the point. So what we talked about in the previous video was the formula that we have for the current, which was basically dq of t over dt, or derivative of the charge with respect to time. And what we have in here is actually we have the current in this question over time. And if we just cross multiply in here, we can figure out that the dq of t is equal to I times dt. And if we want to find the q in here, we basically have we can do the integral on each side. So we're going to have the integral of I of t dt, and we're going to have the time points that we have. So what we can do in here is that we can do the reverse of what we did in the previous question. So we're going to find different regions, and in those different regions, we're going to put the time points that we have. But so we're going to have another shortcut for integral, which is basically is the area that we have in this graph. So as long as we can figure out this area, that's going to give us the total charge that the question is asking us. And for finding that, it's actually pretty easy. You're going to have this right triangle in here plus this rectangle, and that's going to give us the overall charge. So let's see how we can figure that out. So if we want to find the area of this right triangle, we're going to have 10 times the base, 1 divided by 2, and we have to watch for the units that we have. We have milliamp and millisecond, so milli times milli, so 10 to the negative 3 times 10 to the negative 3, it's going to be 10 to the minus 6, or it's equal to micron. So this is going to be micron coulomb, and we're going to have the area of the rectangle. This side is 10, the other side is 1, so 10 times 1. We're going to have the same unit, microcoulomb, and yeah, this is going to be 5, and this is going to give us 15 microcoulomb as the final answer for this question. If we want to go with the integral part, so what we need to figure is that, first of all, we have two different regions. So we need to figure out the equation for I. So in the first part, from 0 to 1 millisecond, we're going to have this slope in here, which is basically 10 divided by 1. So the equations for that part is, so we're going to have from 0 to 1, the equation would be 10 times t, and for the other part, from 1 to 2, we basically have a constant value for I, which is 10t, and that's how we can get it. So if we want to take this out, we're going to be having 5t squared from 1 to 0, and 10, forgot the dt here, and this is going to be t naught, and that's going to give us 10t going from 2 to 1. So from this part, we're going to get 5 minus 0, and from the second part, we're going to have 10 times 2, 20 minus 10. This is going to be 10, this is going to be 5, and we're going to get the same 15 microcoulombs that we got in the previous part. Again, as long as we have simple shapes in our graph, it's easy enough to find the area, and we can use the shortcut that we have. Hope everything was clear. Let me know if you guys have any questions. You guys take care. See you in the next video. Have a good one.